All right, our last example in 11.5 is another equation that we're trying to solve that doesn't quite look quadratic. It doesn't have a t squared and a t. This one now has a t to the 1/2 and a t to the 1/4. Maybe you can try this one on your own. Maybe try pausing the video, see if you can use our u substitution techniques. Figure out what to call u, figure out what u squared is, and see if that will work to be able to rewrite this into a quadratic form. Then solve it for t. All right, I'm going to call u t to the 1/4. That means squaring u would really be t to the 1/4 squared, or t to the 2/4. And if I reduced it, I end up getting t to the 1/2, which is perfect. That means I should be able to take out my complicated pieces of my original and use u substitution. I could really say that t to the 1/2 is the same thing as u squared, plus 3 times u, because u is the same thing as t to the 1/4, plus 2 equals 0. So now I have a quadratic equation, u squared plus 3u plus 2 equals 0. And now I can solve using my quadratic techniques. Try to factor first if that works, and then possibly use quadratic formula. Don't forget though to back substitute in and really solve for t and not u. It looks like this one factors into a u plus 2 and a u plus 1. I can set each of those equal to 0, and I end up getting u equals -2 and u equals -1. Let's go ahead and back substitute, because we don't want to solve for u, we really want to solve for t. Remember, u was the same thing though as t to the 1/4, so I end up getting a t to the 1/4 equals -2 and t to the 1/4 equals -1. Well, look at this. So we've seen this before, haven't we? Where we have a fraction exponent, a rational exponent, and we know that we can take that rational exponent and always make it into a radical, right? Do you remember top dog goes in the house? So I should be able to take this t to the 1/4 and really make it into a 4th root of t. So I can say that the 4th root of t equals -2 and the 4th root of t equals -1. Uh-oh, you might have had a red flag, did you? Remember, we can't have an even root ever equal a negative number. Remember, the square root of x can't equal a negative number. Well, that also means then the 4th root of t can't ever equal a negative number, right? So that means on this one, we have no solution. Now, you might not have gotten that if you tried to raise both sides to the 4th power. You might have gotten answers that actually look normal, t equals 16 and t equals 1. So it's really important anytime you have those rational exponents or radicals that you always double check your answers in the original to make sure that they work. In this case, both of them didn't work. They were both extraneous solutions, so I end up having no solution to this equation. Sometimes both answers don't work, unfortunately. Sometimes they both do, and sometimes one works and the other one doesn't. So it's really important that you're paying attention to your equations and then always double checking your answers to make sure that they work.